So it's certainly in some respects the more obnoxious component of the exam. There are a series of questions that students sometimes neglect to review when looking at metabolism. And it is the stuff at the very beginning of that metabolism lecture that had to do with the preference for oxygen, the terms that are used to describe the preference for oxygen, and how that impacts where they are going to grow in something like a fluid thyroid glycolate. Right? So far, so good? So, there is a term that means capable of using oxygen to generate energy. What's that term? Aerobic. Perfect.
I was gonna say that.
There is a term that means not capable of using oxygen to generate energy. Anaerobic, right? Because if one is aerobic, the other one is anaerobic, right? That's the definition of those terms. But what we said is those terms get used in a confusing manner sometimes, right? And I said there were a couple of questions that are often by y'all considered to be trick questions, right? And you can just anticipate at least one of them showing up. Sometimes it's just a straight up definition though. An organism that is incapable of using oxygen to generate energy is an anaerobe, right? True or false?
Did you say incapable?
Incapable of using oxygen makes you an anaerobe. True or false?
True.
True. Sometimes the question shows up in unanticipated mechanisms, right? So for example, I'm gonna hold off on that actually. So sometimes the definition questions are a little trickier, right? A facultative anaerobe is capable of using oxygen to generate energy. Is that true or false?
True.
True, right? So that means that a facultative anaerobe is in fact an anaerobe. True or false?
True.
That's
False.
false. Facultative anaerobes, despite the name, are
Oh, it's false.
aerobes.
Yeah.
Because what y'all told me just a question before was that they can use oxygen. Facultative anaerobes are aerobes that have the faculty of growing anaerobically. Right? That's confusing point number one. Aerotolerant organisms are aerobes. True or false? Because what are they? Why are they anaerobes? Yeah, they tolerate it. They don't use it, but they don't care if it's there. All organisms, though, are. Yeah, let's do it this way. So, an obligate aerobe has to use oxygen to generate energy. Is that true or false? Right? That makes sense. An obligate anaerobe is an anaerobe. True. Right? Obligate anaerobe is definitely an anaerobe, right? That's only confusing because a facultative anaerobe is not an anaerobe. So what's special about an obligate anaerobe? What's the one thing that you need to know about that one?
It's up at the top.
Well, yes, but that's not, what's,
It has to have oxygen.
no.
Oh, wait, what are we talking about?
It's not that it doesn't have to have oxygen. It
Likes it.
can't have oxygen. An obligate anaerobe is killed by the presence of oxygen. So far, so good? So, when life first developed on the planet, would you expected most organisms to be obligate anaerobes or obligate aerobes?
Anaerobes.
Why?
Well, because there was no
There's
oxygen.
no oxygen. You couldn't have had any obligate aerobes when life first arose. Does that make sense? And again, that's not spelled out anywhere in the PowerPoint slides. But if you understand that an obligate aerobe needs oxygen, and you understand that at the beginning of life there was no oxygen gas, right, then couldn't have had any obligate aerobes at the beginning. Everybody understand? All right. So again, there are always questions like that that catch you off guard, right? Because you haven't thought about it before, right? Which means you have to think about it in the middle of the exam, which is sometimes not your favorite thing to do. All right. So an organism that grows only at the top of the tube in a fluid thioglycolate tube is what? Yeah, obligate aerobe. Organism that grows all throughout a fluid thioglycolate tube is what?
Aerobe.
Well, I'm getting a couple of different answers. What did you say? Yeah, that's one of them. What's another one? Yep, perfect. So we're like on a boat. So the problem on an exam is one of those answers might be in the answer choice. Both of those answers might be in the answer choice, right? And then you got to modify your answer accordingly. Right? But we've been through the ringer once, so we know how to handle that. So now we said oxygen's actually toxic to everything, even the stuff that uses it, right? And we said that stuff that uses oxygen has to be able to detoxify the toxic byproducts of living in a world with oxygen, right? And those toxic byproducts, those are called reactive oxygen species. So, and we said organisms make enzymes that detoxify those compounds, right? For example, there is a reactive oxygen species, hydrogen peroxide. And we said that organisms detoxify hydrogen peroxide using an enzyme called catalase, right? And we walked through the logic there. So far, so good? All right. So, which of the following organisms is least likely to produce catalase? And your choices are obligate aerobe, aerotolerant, facultative anaerobe, obligate anaerobe.
I feel like you should put the choices on the board. So I can sit here and look at it for a second.
Mercedes, what is it?
It would be an obligate anaerobe, right? Because they don't have oxygen, and for a catalase, you have to have oxygen, right?
You do not have to have oxygen for the enzyme.
Okay, then,
Facultative. Facultative. Wait, oh, no.
Okay, that's the second time I've heard that answer. The logic was wrong there, so.
but
what's
I
the
was
logic?
right. It's an obligate anaerobe.
Is that what you're saying?
So we think this is the one that is least likely to have catalase. Why?
Because it's killed by oxygen.
That's why.
See, but I was like,
Getting the
Sort of.
right answer for the wrong reason.
but I was
is
on the
not our
right
goal.
track.
So
I knew it had to do with oxygen.
this enzyme allows you to live in the presence of oxygen. This organism cannot live in the presence of oxygen, and thus likely does not have that enzyme. Does that make sense?
I was on the right track.
you were on the right track. And you got the right answer, which for y'all, for your end of the table, that's the only thing that matters, right?
Well, no, because I actually would like to understand all this.
Well, why isn't it facultative anaerobic?
Because
Yeah,
that
because it
can,
doesn't care.
yeah,
Why is it air tolerant?
because
Because it can be in the presence,
all like, hey,
it can tolerate
oxygen.
it, right? Why can it tolerate it? Well, it can tolerate it because it can make an enzyme like catalase, right? Everybody understand? Alright. So, again, question you might not have anticipated ahead of time, right? So, but the information is there if you understand the significance and the context of the information. Alright. So that was the first chunk of metabolism. We talked about kinetic energy, we talked about potential energy. That stuff is usually pretty approachable. We said that there were a series of chemical reactions that you had to know. And you have to know them backwards and forwards, right? And I realize that this is an online test. And I realize you're doing it at home. But there is no substitute for knowing those chemical reactions backwards and forwards, right? And so my recommendation is still what it would be for a face-to-face class, which is to go home and write down those chemical reactions until you get comfortable with them backwards and forwards. Because that is how you make sure that when you get to the questions that deal with these chemical reactions, you're not going to slip up in your haste, right? Because that timer's clicking down. So there are a couple of chemical reactions that y'all typically forget about that, right? And I see it every single semester, and I see it regardless of whether it's an online test or not, because again, I've done online tests before. So y'all understand that you've got to do aerobic respiration, and you understand that you've got to do fermentation, but the thing that you forget is those stupid piddly little reactions for ATP. Right? But those are chemical reactions and you have to know them, right? So, gotta know reactants and products, right? In the case of this, but you also got to know the name of the reaction. What's the name of that reaction?
ATP.
that's,
ADP,
Phosphate.
not phosphorylation,
halogenation.
hydrolysis.
Hydrolysis.
Perfect. So,
Bonus point for her. No.
I don't typically give bonus points during the review because not everybody is in attendance and thus eligible to get them. All right, but that's hydrolysis. And then we have the other one.
That's phosphorylation.
What's that one?
Phosphorylation.
Phosphorylation. So,
What's your second?
not ATP phosphorylation though. ADP phosphorylation. And sometimes I just ask you the name, right? Sometimes it is the name that I am hunting for. So, but I tell you, ADP phosphorylation and ATP phosphorylation look really similar on a test. And I wouldn't necessarily do that, but I wouldn't necessarily not do that either, right?
I mean, you are a Richard, so.
So, it without a doubt. So, which one has energy as a reactant?
As a reactant,
Mm-hmm.
that would be ADP phosphorylation.
Yep, there's my two right answers, right? So ADP phosphorylation. So, and that's what we said is actually the most important, right? Is where is the energy? Is it a reactant or a product, right? If it's a product, that's ATP hydrolysis. Which one uses ATP as a reactant?
ATP hydrolysis.
Right. So there are questions that are just going to be who's your reactant, who's your product, right? So understand the reaction, understand the arrows, understand that the direction is what determines it. And there's no fundamental difference between hydrolysis and phosphorylation except for the direction of the arrow, right? So, So don't forget about this. There is going to be a series of test questions that are going to start off with one of two phrases, right? Or that it will have embedded somewhere in the question one of two phrases. In an aerobically respiring cell, or sometimes just in a respiring cell, and then in a fermenting cell, right? And you need that information to steer you in the right direction sometimes. So look for it, right? And if it's there, make sure that you make note of it, right? Because if you answer a chemistry question about fermentation in a cell that's respiring, you got it wrong. So respiration, the word respiration means that you run glycolysis, that you run the citric acid cycle, and that you run the electron transport chain, right? So anytime that word respire shows up, it is those three things. And we said there were two kinds of respiration. There is the respiration that has an electron, terminal electron acceptor that is oxygen, and that's aerobic respiration. And then there is electron transport that uses something other than oxygen as a terminal electron acceptor. And that's not aerobic respiration, that's anaerobic respiration. Right? So far so good? And then, and I know, right? It's super fun. We love it. And then there's that other thing, fermentation. Right? And that's totally different. If I use the word fermentation, you use glycolysis, but you don't use the citric acid cycle, and you don't use electron transport. With fermentation, instead you do this other thing after glycolysis, and that is the fermentative step, right? So there is fermentation as a whole, which is both things, and then there's the fermentative step, which is just that second reaction, right? So sometimes, again, I do something unexpected, right? And something unexpected is typically linking it to another concept somewhere, right? So, a cell that is using anaerobic respiration might be which of the following, right? And your choices are obligate, aero, or obligate, anaerobe, or facultative anaerobe.
We're gonna
So,
go with
you're
A and C.
using anaerobic respiration. Could you be that?
Yes.
No. Because obligate aerobes have to use aerobic respiration. They have
Wait, what are we talking
no
about?
choice.
No, that's what you just said. That's what you said, aerobic.
Anaerobic respiration.
Oh.
Easier
See, I
to
thought you
read.
said
Yeah.
aerobic
So
too. That's what I'm
anaerobic
like,
respiration. So a cell is using anaerobic respiration. Could it be that?
Then
No.
the bottom two,
Could it be that?
yes,
Well, no, because that's just obligate, right? Never mind.
yes.
was a dumb question. We're
Yes,
good.
because,
Could it be that?
yes. Yes.
Yes. Because this is an aerobe that has the faculty of growing anaerobically. And one of the ways that you grow anaerobically is through anaerobic respiration. Could you be this? No, let's do. Could you be that?
What does that say?
Aerotolerant.
Aerotolerant, yes.
Yeah, because it's got to use something, and that something could very well be anaerobic respiration. So, again, chemistry matters, and so you have to link it back to why it matters. Why it matters is what the organism is doing with it. All right. So focusing now on aerobic respiration versus fermentation, because that's the major split to make. Anaerobic respiration is more of a side road, right? aerobic respiration, what we said is we've got glucose, we've got oxygen, and we're going to yield water, carbon dioxide, energy. Right? That's aerobic respiration. And I could very simply ask you which of the or no, let's just do it as true or false because that's easier. So pyruvate is a product of aerobic respiration. True or false?
True.
Gosh, it sounds like it would be, doesn't it?
I thought pyruvate is up there, so then it's false. Damn it. Fuck my life.
Pyruvate has something to do with aerobic respiration.
But yeah, because now I'm just remembering whenever you broke all that down.
Yeah, no, I know.
And I seen all the
But if you
pyruvates on
look
there.
at the whole reaction, which is what the question is, because I say in aerobic respiration, and that thing there is telling you what your overall reaction is, right? In aerobic respiration, pyruvate is a product. And you look at the product side, and you ask yourself, do you see pyruvate? And the answer is no. Is it going to show up somewhere? Sure, right? But the reaction itself does not have it as the final product. All right, so far so good? All right, so I do sometimes ask about the overall chemical reaction. But I also spend time asking about the sub-reactions. Right? And we said glycolysis, going to be glucose to 2-pyruvate energy. We said citric acid cycle going to be 2-pyruvate to 6-carbon dioxide energy. We said electron transport gonna be this thing here, which we're missing at the moment. All right. So far, so good?
Is that a 602?
Yeah.
Okay.
Yeah, my 6's and my G's start to look a little similar.
Yeah.
So, in an aerobically respiring cell, which step has pyruvate as a product?
Glucose.
Glycolysis.
Glycolysis.
That's how the pyruvate reads its head.
That's what I was thinking. Whenever you-
I know, but again, I anticipate that to some level, right? And so I know that there are going to be some percentage of students who want to tell me that pyruvate is something to do with aerobic respiration. And it does, just not in the global reaction.
The product at some point looks like it's used up.
Exactly. All right, so products and reactions for the whole thing, but also for each of the
I have my
substeps.
feelings.
Right? Also, got to do the same thing though with fermentation. So in a fermenting cell, your chemical reaction looks like this: glucose. I'm running out of room. And what's the final product that we said is going to be our placeholder?
Fermentation.
Lactic acid. Less energy.
All right.
Is there supposed to be a plus energy on the end of that?
I don't know, is there?
I mean, I need to study my cards.
Yeah. So what we said is that the purpose of the fermentative step is not to produce energy. And most forms of fermentation, including lactic acid fermentation, produce no energy during the fermentative step. So what step produces the most energy in a fermenting cell?
E.T.
Glycolysis. Can't be electron transport because there is no electron transport in a fermenting cell. So this is where you have to look for the cue. If I say fermenting cell, I mean that stuff on the right. If I say respiring or aerobically respiring cell, I mean this stuff on the left, right? And so I'm gonna have a question where I say this thing in a fermenting cell, but I will give you answer choices from a respiring cell as well, so that I can see who is actually taking the time to read the question critically and who really knows the answer and is not just jumping to a snap conclusion without thinking about what is being asked. All right.
Not I.
Yeah, I really need to study this
Yeah,
section.
but that's why we're doing this, right? We're doing this because what I don't want you to do is to walk into that test thinking that it's an online test and you've got it made, right? You just don't have to worry about it, right? There is no substitute in these tests for doing the legwork and learning the material, right? So, in an aerobically respiring cell, the step that produces the most energy is what?
I'm sorry, in the anaerobic,
Aerobically respiring cell.
E.T.
Electron transport, right?
That's what I got confused.
In a fermenting cell, the step that produces the least energy is
Ferment.
what?
E.T.
ferment.
Fermentation. It can't be electron
Oh, 'cause
transport
it's-
because it's not happening.
It's not happening.
Yeah, look, you look at
Well,
the
that would mean it would
fermenting
be the
side, there
least,
is no
right?
ET
Because there's
over there,
nothing.
okay?
In an aerobically respiring cell, which step produces the least energy? Do you remember? It's not indicated on the board, so you have to.
Glucose.
You said it's not on the board.
Oh, it's not on the board?
Wait, I don't know anymore.
The least energy, the least ATP, let's say ATP, least ATP, in an aerobically respiring cell.
What does it start with?
ATP! ATP hydrolysis.
The
AD.
text of both of these two. They each produce two equivalents.
My arm, get off my arm.
Would
I'm so
I do
tired.
that on a test and have a both A and B? Yep, sure would.
Of course
Wait,
you
is there both the A and multiple select
It's
questions?
called
Is there gonna be
D.
a choice for both A and B?
Yeah, I don't make
and
you
B.
bubble in multiple answers. There is A, B, and if A and B are both correct, there will be another answer choice that says both A and B.
Do you ever put that and that's not the right answer?
Yes.
Yeah.
Yeah. I
absolutely
mean, we're
do.
talking about Professor Wirt here.
All right.
He takes his name seriously.
Dick.
I live down to the net.
Yeah. He lives down the name, taking it completely serious.
You should know that.
I don't understand. Yeah. I mean, what is this, like your first class with him?
I'm getting attacked today. for no reason.
I was just joking, just joking. Just kidding!
You're the first name going in my note tonight.
Do you have a black book? I'm in it?
No, that's my suicide note.
Oh, Don't talk like that. Cause then I'm gonna have to call the people.
Yeah, the police hotline.
Please do.
I'm gonna be like, I'm worried about him.
I'm gonna get, what's that called? EDO?
Okay.
All right. In a fermenting cell, which step produces the most NAD?
NAD.
Glycolysis.
No.
They're both the same.
No.
No.
Wait, produces?
Yeah.
Then it's
Fermentation.
fermentation.
What? I thought that says 7 NAD up there.
No,
It's
it's
two.
two.
This is
So
two
2 NADH. This one doesn't produce any D at all, it produces NADH.
Oh,
That one produces NAD.
see, that's why I got it wrong, cause your
It's
handwriting.
terrible.
He says that.
That's why I'm not writing down the answers for you. Right?
Tell us something else we don't know.
So in a fermenting cell, which that produces the most NADH.
Glyco.
Yeah. So in an aerobically respiring cell, glycolysis produces the most NADH.
False.
Right? And
I missed the question, it was so quick.
In
It'd be
an
citric.
aerobically respiring cell, glycolysis produces the most NADH.
And then it's false, cause
Oh,
citric acid,
false.
up there it says 10, right?
Yeah, it would be lactic acid.
Yeah, and so clearly in electron transport, you produce the most NAD, correct?
Yes, true.
Right, because 12 NAD, right?
Yes.
So, and in a fermenting cell, the step that produces the water is the electron transport chain.
No electron transport chain. False.
There's no water, there's no electron transport chain, right? Because it's fermentation.
Yay, I got one right.
All right. So in an aerobically respiring cell, the step that uses the oxygen is electron transport.
That uses the oxygen?
Yeah.
Yeah, electron transport.
Right. So in a fermentation, in a fermenting cell, the step that uses the oxygen is the fermentation step.
No oxygen. False.
False. In an aerobically respiring cell, the step that that uses the oxygen is electron transport.
Yes.
False.
Wait, that uses the oxygen?
I thought you just
In
said.
an anaerobically
Oh.
respiring cell,
You gotta
the step
enunciate
that
the Anna,
uses.
Yeah, I feel like you need to like,
cause I heard.
That's
Anna.
why I don't read the test to you.
yeah, exactly. That's the problem.
We
You're
get
saying
bonus
it
10
out
points
loud.
to read the test.
Yeah, that oral examinations are terrible. All right. In an anaerobically respiring cell, the step that uses the oxygen is electron transport.
False.
False.
Because the step that uses the oxygen in an anaerobically respiring cell is the citric acid cycle.
False.
Also false.
Because there's no oxygen.
Because it's anaerobic, because there is no oxygen.
I thought you were stating that, and then I was like, wait,
There was a lag there at the end. I knew it was an answer.
I glitched out.
So, in a cell that is respiring,
Wait, what are we doing?
in a cell that is respiring,
Sweating.
the terminal electron acceptor might be oxygen.
If it's aerobic
Does it?
respiration.
Well, no, not.
I didn't say aerobic respiration though, did I?
No, you
I
said
said
it's
in a cell that is
respiring.
respiring. The terminal electron acceptor might
What
be
is-
oxygen.
what is
That's true.
respiring?
If you say might be,
Sure.
then true. If you say has to be, then false.
If in a cell that is respiring, the terminal electron acceptor might be pyruvate.
False.
I'm sorry, I didn't hear it. She was talking.
In a cell that is respiring, the terminal electron acceptor might be pyruvate.
Well,
False.
glycolysis is pyruvate.
False.
False. What is it if your terminal electron acceptor is pyruvate?
Fermentation.
Yeah. Say it loud.
Fermentation.
Fermentation.
Good job.
Can you explain that?
Yeah,
That's
terminal
not-
electron acceptor is whatever you finally
Finally.
dump
It's
your
recording.
electrons onto at the very end.
What is
My very end
this?
is here, my electrons are being dumped from here to here. And so that's my terminal electron acceptor.
What is this
For the same
respiration?
reason that this is my terminal electron acceptor here. It is the thing that is receiving the electrons at the very end.
Okay, when you stated the question, can you restate the question?
I doubt it. What question am I restating?
Cause you're using a word and I'm like, I don't understand what that means.
Respiring.
Yeah, what is that?
Respiring means you are using glycolysis, citric acid cycle, and electron transport without telling you any information about what the terminal electron acceptor is. We said there are two kinds of respiration, respiring. right? Respiring and
So,
respiration are the
okay,
same
so we
word.
have to guess whether it's,
If I don't specify, it could be either.
okay,
So I could say in a respiring cell, the terminal electron acceptor might be iron. Yeah, true, right? Could be anything as long as it's not pyruvate.
so if it's pyruvate, then it's automatically
Yeah.
fermentation.
Yeah. If it's oxygen, it's automatically aerobic respiration.
Okay, but there's pyruvate over here in this.
Yeah, but it's not the in. Terminal
Oh.
means the in.
Okay.
Right. So, in an aerobically respiring cell, oxygen is reduced to water.
Yes,
True.
it's right there on the board.
Yeah.
Good job. 602, 12 NAD.
Oxygen becomes water, that means it gains electrons, that's a reduction. Right? Gain a hydrogen, you gain the electrons, and you're reduced. So, what step in aerobic respiration is reducing NAD to NADH? Yes. Or what if that's not the answer choices? Glycolysis, right? One or the other, or both. So, in an aerobically respiring cell, the step that reduces pyruvate to carbon dioxide is what? Nope.
Wait, ask your question again, please.
In an aerobically respiring cell, the step that reduces pyruvate to carbon dioxide is what?
Lactic acid.
And they told me citric acid cycle, but
Oh.
that's not right. Why is it not right?
Electron transfer?
Because pyruvate to carbon dioxide is not a reduction, it's an oxidation. Right? There is no step in aerobic respiration that is going to reduce pyruvate and produce oxygen or carbon dioxide as a result. And the
So,
only reduction that is occurring in that reaction is NAD to NADH.
so what you're saying is out beside the
It's a trick
question,
question.
we need to write oxidation?
It would be none of the above would be the answer.
Right.
So.
And obviously, I was talking about the paper, not
Yeah,
this.
yeah, no, I understand. So, location, right? So, in a gram-positive organism, the citric acid cycle occurs within the mitochondria.
True.
It sounds like it would be, doesn't it?
Damn
There
it.
is no mitochondria in a gram-positive organism, because if I'm talking gram-positive, I'm talking bacteria.
Boom,
Jeez.
Jonah.
It's 12:55.
Yeah, we probably gotta go. All right, so,
You make me feel dumb, Mr. Word.
so,
That felt weird to
so
hear him say
you
Mr.
should
Wood.
not feel, you should not feel that I am calling into question your knowledge.
No, I'm not saying
You
that.
should feel confident that you are willing to speak up when everybody else is being silent, right?
Yeah.
Because speaking up and being wrong is a part of the learning process, and there's
Not only-
nothing wrong with
appreciate
being
you.
wrong at this
I got this
stage.
on
Not
recording
only
for you.
that, but you
Well, you
need to
told me
feel
to shut up.
confident in the fact that you're still going to
All
say
right,
Until you
your
shut
ass
up.
off until you get the
I'm
information.
just,
That's
this was
just
just
the way